we'll be talking about very basic ideas of transformation. Let us assume that y equals f of x is the parent function. Now, how we get gx function when f of x minus a is the relation? So in this case, you can see that x is replaced by x minus a, and we consider this constant a is a positive quantity. So this one is telling me that my graph is moving horizontally a units to the right. Moves. So this one is like the graph is moving horizontally a units to the right. The same one here will be, it moves horizontally a units to the left. So we are taking two more. Px is a function related to f of x. You have f of x plus b, and we say that b is a positive quantity. So then in this case, the graph will move b units upward, and here b units downward. Now, about reflections. Say y equals f of x is again our parent function. So now I'm looking for gx, which is minus f of x. Then my graph will have reflection about x-axis. If the negative sign is inside, then the reflection will be on y-axis. So the situation will look like this. If this is your f of x function, then when you have a negative outside, then it will just reflect along x-axis, and it will look like this. If your f of x is this function, for example, then f of negative x will be this one, which is my hx now. If a is inside, then we'll talk about horizontal stress or shrink. If it is outside, then it will be vertical stress or shrink. Now let us consider a point on the function. Suppose that x naught y naught is a given point on the parent function. So what will happen to this x naught y naught point in f of ax? So it will be simply x naught over a y naught. It will be in the function ax. Now what happens? If my a is greater than 1, so this point will be, this value will be smaller than that one. So then it will have horizontally shrunk. Like, say that you have a point on the function here, f of x is a point here, and my a is, say, 2, say that a equals 2. And if this is the point, say 1, 3, now then this point becomes half, 3. So half, 3 will be here. So the graph is coming towards the y-axis. So it has horizontal shrunk by a factor of 1/2. On the other hand, if my a is, say, 1/3, then the point here is you have 1, 3. So 1, 3 becomes 1 divided by 1/3, which is 3. So then point will move on this side. So then you can see that it is horizontally stressed by a factor of 3. Always you take the reciprocal of this for horizontal. But if that constant is outside the function, then what will happen? If I have a point x naught y naught on f of x, then we will get x naught a y naught on a f of x function. So what happens now, if a is greater than 1, then y value is larger. So if I have a point here, when I make this one here, so then what happens, the point is going up, and also if you have downward, then it will be going down. So that means you can see that vertical stretch. So vertical stretch you have with a factor of a. But if your a is less than 1, so the point, if you have x naught y naught, so then it will be a y naught. If my a is a smaller number, When I multiply with y naught, that will be smaller. So then this point will move here and this point will move here. So that means it is going this way. It is going this way. So it is vertically stretched by a factor of a. We'll give more examples. Suppose I have a point 2, 3 on the given function y equals f of x. Now we need to find the corresponding point for y equals f of 2x. So 2 is inside the function. Now we know that the point becomes 2 over 2, 3, which is 1, 3. So that means when I had a point here 2, 3 here, now this becomes 1, 3. So it is coming horizontally in this direction. So that means you have horizontal shrink by a factor of 1/2 from here. Let us talk about this one now. Say that I have a negative inside, then what happens? Still I will consider my a equals 2. And the negative we take different way, which is greater than 1. When it is greater than 1, so then the point is going inside, close to y-axis. First you divide, so you get 1, 3, and then reflection gives you a negative sign here. So the point will be negative 1, 3, so it will come here. If we now consider this one, say that 2 times f of x, it is outside. Now the stress shrink form will go for the vertical case. So what happens now, the point 2, 3 on f of x becomes 2, 2 times 3, which is 2, 6. So 2, 6 will go here. So then you can see that the point is moving like this. That means we have vertical stretch by a factor of 2. I'm taking one more case. Say that now I have 1/3 f of x. So what will happen to the point? It will be 2, 3 times 1/3, which is 2, 1. So I had a point here 2, 3. This becomes 2, 1. So now it is going closer to x-axis. So that means I have vertical shrunk by a factor of 1/3. I hope you have understood the transformation.